All right. Good afternoon, guys. So we have a short class period today. We're going to be learning about how to graph a square root function. So you should have this note sheet in front of you. So we see the general form of a radical function here. F of x equals a times the nth root of x minus h plus k. We see some things that we've seen before in the past, including the h and the k from vertex form. What this is really referring to is going to be where the starting point, or what we call a critical point, is of our square root function. We're going to use this, what we call a parent function, where there's nothing going on, just the square root of x, as a guide that'll help us start working through some other problems. So if we're going to graph f of x equals the square root of x, we can start making a table. If we started at just 0, the square root of 0 would just be 0, giving us this point here. If we think about what values would give us whole number results as our y's, we'd be thinking about our perfect squares that we could put in for x. So for example, if we put in 1 for x, the square root of 1 is 1. So we see this point here at 1 comma 1. Now we wouldn't jump to 2 because square root of 2 is not a value we could easily graph on our y-axis, right? I don't know exactly what it is off the top of my head what square root of 2 is. So we would think about what our next perfect square is. So our perfect squares, we have 1, then the next one would be 4, right? Because square root of 4 is 2, then 9, 16, something like that. So let's put in 4. Square root of 4 is 2. So we see this point here at 4 comma 2. Then we could put in 9, that next perfect square. 9, square root of 9 is 3. So we see this point here. Let's extend this table a little bit. Let's think about what if we put in a negative number, like if we put in negative 1. Well, square root of negative 1, that's imaginary. Learned about that in Unit 1. That's why this graph doesn't continue anywhere here. Okay, so this graph really does have basically what looks like a starting point, and we call that the critical point, where this graph is beginning. So in this case, our critical point would be 0, 0. So that's where it's starting. If we pick anything to the left of 0, we're taking the square root of a negative number, and we would get an imaginary result. So our critical point for this one would be 0, 0. Our goal for today is going to be if we shift our graph around, reflect it, stretch it, compress it, can we graph it? Okay, so we're going to look at different square root functions with different things going on, either inside the square root, outside the square root, and we'll talk about how that shifts it left, right, up, down. And then we'll talk about kind of what coefficients in front would do in terms of reflecting, stretching, compressing, but it all comes back to this parent function of f of x equals square root of x. Okay, so the way we set this up was I gave us the function. I want us to answer some questions. We have room to make a table, and then we can graph it. Okay, so the first one, f of x equals square root of x minus 5. Okay, so if we think about what's going on here, we have our square root of x, and then we're just subtracting 5 at the end. By subtracting 5 at the end, what this is going to do is it's going to shift our graph down 5 units. So numbers that are added on or subtracted off at the end outside the square root are going to shift things up and down, versus values inside the square root along with the x either being added on or subtracted off, like 3. Those are examples where we have shifts left and right. So the only thing that's going to happen is we're going to have our original graph just shifted 5 down units. Okay, so it'll be this function down 5. So that would mean our critical point here. And the critical point also, we can think of it as the values of h and k from our original function up here. So this is like saying x minus 0 inside our square root. So our critical point would be at 0, and then k negative 5. There's no reflecting going on. There's no stretching or compressing. That'll be when there's coefficients in front, and we'll talk about that later. So then we can make ourselves a table of values, x's and y's. So we're going to start at the x value of our critical point. So at 0, we're at -5. And then we can stick with our values that are perfect squares. Okay, so you could put in 1, square root of 1 would be 1 minus 5, -4. Then we could put in 4, our next perfect square. Square root of 4 is 2. 2 minus 5, -3. We could put in 9. Square root of 9 is 3. 3 minus 2, or 3 minus 5, -2. And let's plot our points. So 0, -5. 1, 2, 3, 4, 5. 1, -4. 4, -3. And 9, -2. So that would be our square root function, shifted down 5 units. Okay. Next one, square root of x plus 3. Okay. Well, if we think about h comma k from our general formula up here, there's nothing going on with the h, so it would just be 0, comma 3. There's no shift left or right. We're shifted up 3 units. No reflecting, no stretch or compress. And we can make ourselves a table. So at 0, square root of 0 is 0, plus 3, 0, comma 3, that's our critical point. Put in 1, square root of 1 is 1, plus 3 is 4. Put in 4, square root of 4 is 2, 2 plus 3 is 5. Put in 9, square root of 9 is 3, 3 plus 3, 6. Let's graph it. 0, comma 3, there's our critical point. 1, comma 4, 4, comma 5, and 9, comma 6. Remember, if we picked any values to the left of our critical point, we would get the square root of a negative number, making it imaginary. That's why our graph is starting right here. Okay. All right, next one is where we got to refer to our formula carefully. So this one says in the square root of x plus 2. Okay, so now there's nothing going on out here. Okay, so we don't have a shift up or down, but we do have a shift left and right. Okay, so if we think about where our critical point would be, this is similar to what we had in the last unit with vertex form, where we have to flip the sign on whatever we have for h. Okay, so if it's x plus 2, our critical point would be at -2, comma 0. So if our original parent function f of x equals square root of x had a critical point at 0, 0, and now we're at -2, comma 0, this is actually a shift left 2. No reflecting, no stretch or compress. We'll talk about those in the later ones. Okay, so now let's graph it by making a table. So we have to be a little bit more particular about how we check our values now. So we're going to start at -2, not 0, because that's where our critical point's at. So -2 plus 2 equals 0. Square root of 0 is 0. But we're still going to go up by those same values, going up by 1, then adding 4, then adding 9. But we have to do it to the -2, okay? Because we want the results to be whole numbers when we take the square root. So if we put in -1, -1 plus 2 is 1. Square root of 1 is 1. Next, we can add 4 to -2. Okay, so then we'd be at 2. 2 plus 2 is 4. Square root of 4, 2. we can add 9 to negative 2. So we get 7. Square root of 7 plus 2 is square root of 9. Square root of 9 is 3. Okay. And we can graph it. Negative 2 comma 0. Negative 1 comma 1. 2 comma 2. 7 comma 3. Okay. So that's one where we shifted left or right. Let's go to the next page. Why don't we do, how about let's look at number 5. We're going to jump around a little bit. So 5, our critical point, remember if we want to write out our formula from the front side here, f of x equals, and we can just write the square root part. Okay, so we'd have f of x equals a square root of x minus h plus k, where h comma k is your critical point. So let's look at 5. So our critical point, we flip the sign on what we have inside the parentheses, so it'll be at negative 1, negative 3. So we took our original function and we shifted it left 1, down 3. This negative in front is like saying negative 1 times, so that is going to reflect it. Okay, so we can say yes there, and there's no stretch or compress. So when we multiply by a negative 1, that's going to just flip everything around. It's going to make it go down instead of up. So we'll see that in this one. Make ourselves a table for x's and y's. So we'd start at our critical point, negative 1, negative 3. Okay, so if we added, or if we put in, so if we think about what we would put in for x, so we put in negative 1 here at the beginning, so negative 1 plus 1, that gave us 0. So we want to make this become a square root of 1, so we could put in 0 for x. So we put in 0, 0 plus 1 is 1, square root of 1 is 1, but then we got to take the negative of that, so it'd be negative 1 minus 3, it'd be negative 4. Okay, then we'd want to go 4 units away from negative 1, so we'd be at 3, right? Because then we'd have 3 plus 1 is 4, square root of 4 is 2, then negative of that, so negative 2 minus 3, negative 5. Then we got to go 9 units away from negative 1 to get the next perfect square. Okay, so that would be 8. So if we put in 8 for x, 8 plus 1 is 9, square root of 9 is 3, negative 3 minus 6, negative 6. That's right, negative 1, negative 3, 0, negative 4, 3, negative 5, and then 8, negative 6. There's our function. And if we picked anything to the left of negative 1, we'd be getting a negative inside the square root, and then that would make the whole thing imaginary. Okay. So we have some more on here. Maybe let's just do number 8. Okay, so f of x equals 1/2 times the square root of x plus 5. Okay, so our critical point, 0, 5. There's no shift left or right because there's nothing inside our square root. We're going to be shifted up 5. There's no reflection. And this time we're compressed by 1/2 because we have that 1/2 in front. So we'd start at our critical point of 0, 5. Now this is going to scrunch our graph. So watch what happens. We put in 1 here. Square root of 1 is 1, but times 1/2 is 0.5. plus 5. So this is really 5.5. So instead of going up to 6, we went up a half. Then we put in 4, the next perfect square. Square root of 4 is 2. 2 times a half is 1 half, or 1. So 1 plus 5 is 6. Put in 9. Square root of 9 is 3. 3 times 1 half is 1.5. 1.5 plus 5, that'd be 6.5. So we're only going up by a half each perfect square this time. We can plot these points. Six, 9, up 6.5. So it's compressed down, scrunched down by a half. All right, so for today, with our short class period, I'm going to ask that we do the rest of these problems on your own. I'll put a key in our Google Drive for you to look off of. I'm going to reteach this stuff on Tuesday when we come back. So we'll go back through a worksheet going over all this stuff again. Then we'll go into cube roots. Okay, so this is something that I will come back to again on Tuesday when we come back. All right, so our homework is finished the rest of this packet.